All right, let's graph some of these cosine curves. Cosine, between the two curves, sine to me is much nicer to graph than cosine. Not that it's hard, it's just kind of a, I don't know, sometimes I find cosine a little annoying. But anyways, we're going to start with the same approach. So the absolute value of the coefficient, so this case it's just 1. The period, still 2 pi divided by the b value, which is 4. So the period is going to be pi over 2. Now cosine, this is how it's typically drawn. They normally start it on the y-axis just like you did for sine, just because it's starting on 0. I don't know if you can hear that, but my daughter is a little upset, which is, yeah, she's not by herself. Her mom's with her. She's just loud. So this is what we're going to do for cosine. It looks a little weird. It also kind of helps distinguish it from a sine curve. It's like, wait, what did we just graph? Since they're both waves. But the reason why I find it a little annoying is because the intercepts aren't exactly, right in the middle like they were for sine. So the period, that's still the distance or still the length of the curve. So that's pi over 2. But there is a little trick to getting the intercepts somewhat quickly. You still can figure out what is in between them. So like what is in between 0 and pi over 2? Well, that would be pi over 4. So then these two intercepts are in the middle of each section. So what's in between 0 and pi over 4? Pi over 8. And then in between pi over 4 and pi over 2, that would be 3 pi over 8. And if you're going, wait, how do I figure out what's in between them? Just take an average. Just add the two numbers together and divide by 2. And it bounces between 1 and negative 1. All right, let's try it again with the next one. So here A is 85. The period, 2 pi divided by 1/8. So the period is 16 pi. So this is a pretty big curve. If you drew it just scale, it would be massive. You'd need more than one piece of paper to do it. That's why we like not drawing a scale. Okay, so start up here. Draw your cosine curve. So it's still going from 0 out to 16 pi. That's the period. Cut it in half. That's 8 pi. So then the intercepts is in between 0 and 8. So 4 pi. And between 8 and 16, that'd be 12 pi. And then it's bouncing between 85 and negative 85. So cosine, it's a little bit different than sine as far as the graphing, but once you kind of get into a groove and get into a pattern, it's not that bad to do. Figuring out, cutting in half and cutting in half again, that gets pretty quick. Okay. Next example. So the A value is going to be 7. The period, 2 pi divided by 2 pi. So the period is 1. So the length of the whole curve is 1, which means you're going to be dealing with some fractions as intercepts. Okay, so it's got a length of 1 from start to finish. So if you cut it in half, that's a half. So in between 0 and a half is a fourth. And in between 1/2 and 1 is 3/4. And then you're bouncing between 7 and -7. All right, for H, your amplitude is going to be a positive 11. And the period, 2 pi divided by pi over 4, which is going to equal 8. Okay, so the curve itself, though, it has that negative in front of it, so that means it's going to start down at the bottom and get flipped upside down. Okay, so that whole distance is 8. The halfway point would have to be 4. So between 0 and 4 is 2, and in between 4 and 8 is 6. And then it's bouncing in between 11 and -11. Okay, let's go ahead and do part I. Part J, I'll leave that for you guys to kind of ponder and check out the notes, or the key. And see on that one. So on I, it's a little bit different because now you've got things that have been are going to shift down, which we haven't really talked about with trig functions, but we've talked about it with other functions. So your amplitude is the same way as before, it's just 3. The period (2 pi) divided by 3, and that's all you can do, it doesn't simplify. And then we're going to shift down by 3. So sine normally starts at 0, but it's not going to with this one. It's going to start on y equals -3. Well, its amplitude is 3. So it's the distance from the center to the top is 3. So when it reaches the top of the curve, that's when it hits the x-axis. And then the rest of it goes like that. So it's bouncing in between 0 and -6. Whoops, drew that a little low. That's all right. The period is 2 pi over 3. And this time the intercept is no longer in the middle of the curve. It's kind of occurring how it did for the cosine. So this middle is in between 0 and 2 pi over 3, which is pi over 3. And then that intercept is in between 0 and pi over 3, which is pi over 6. Okay, so that's going to do it for this section. Be sure to look at this example or just try it out, see how you do. That's it for the section. In the next section, we'll talk about the graphs of the other 4 trig functions. And then in 6.6, we're going to start to slide them to the right and then slide them to the left. So try the homework out, see what you can do, have fun with it, and let me know what you have, or let me know what questions you have.